Hey, Algebra 2 kids. This is Dr. Callahan for Algebra 2 Semester 2 for week 2 Friday. Happy Friday. I know we're on a distance learning today, so go ahead and take a look at the following and answer the 3 questions on your warm-up log. So nothing's really going to change. I'm just going to go ahead and teach you guys as if you are here in class, and then you can just go ahead and copy down the notes and then complete the activities, exit ticket, etc. All right, so let's go ahead and take a look at this. So here are the following 5 steps to solve the first question. You have to first multiply to get rid of the fraction, distribute to get rid of the parentheses, combine your like terms, and then move the variable to one side of the equation. In this situation, your variable is an x. You're going to move the variable over to the left, and then solve one of the coefficients to get x by itself, and then you should have your answer. So pause the video and make sure you show the work on your warm-up log. Just to put things into perspective, this week is week 2. Next week is week 3. So today is week 2 Friday. Your finals is going to be on week 20. So then after this week, you have 18 weeks left. All right, so today we're going to go ahead and continue on with skill number 3, which is identifying zeros and roots. Keep in mind that for your week 2, you have your quiz that is assigned on Math Excel, and it's due on Sunday by 11 p.m. You also have your homework for week 2 that is on Math Excel, and it's due on Sunday by 11 p.m. as well. You will have some extra time today to kind of work on your Math Excel at home and just make sure you submit it. There are 10 questions apiece, so make sure that is completed. This is what you should be able to see. These are the first 2 that you see on Math Excel, your homework for week 1, and then also your quiz for week 1. That is already due, but if you still need to turn it in, you're welcome to do that. The sooner you turn it in, the less penalty you'll have. The longer it takes you, the more penalty you'll have. And so the penalty is generally 10 to 40% off of the original grade. And then take a look at week 2. This is your homework for week 2. And then right here, this is your quiz. I'm sorry. This is your quiz, and this is your homework. Yeah, and now I just realized. So the circle is actually going to be the homework, and then the squares are going to be the assessment or the quizzes. All right, so today we are on Friday, and so you have a little bit of time to go ahead and practice with your Math Excel. So let's go ahead and get started. Yesterday when I saw you guys was Thursday, and we talked about making a brochure on the conjugate root theorem, and today we're going to continue on with that concept. So for today's material, you're going to need your guided notes on the conjugate root theorem, and you need to have your handouts. All right, so in your white guided notes, make sure you turn over to this page. We're going to go ahead and start this off by saying let p of x be a polynomial if a plus the square root of b is a root, which means you can potentially find a 0 of this polynomial p of x. Then the conjugate means it's opposite of this. So a minus the square root of b is also going to be a root. Now that is synonymous with not just square roots, but you can also do that with imaginary numbers. So let p of x be a polynomial function. So if a plus bi is a root of p of x, then similarly a minus bi is also going to be a root of p of x. So notice that this again does not just apply to square roots, but it also applies to imaginary numbers. And that is the summary of the conjugate root theorem. So let's go ahead and put this into practice with an example. Okay, so taking a look at the first one right here, it says Ronaldo said that a polynomial equation for a rational coefficient has a 0 of this right here and this right there. So keep in mind these are zeros, okay? And it has a degree of 4. Is Ronaldo correct? He is correct, because if that's a 0, then you know your root is x minus -1 plus 2i. And then similarly to that, you know the conjugate root theorem says it's going to be x plus -1 plus 2i. So these are going to be your first and second roots, or I guess it could be degrees once you solve them. Then your third and fourth one is going to be this one here. So you have x minus 3 plus a square root of 5. That's your third. And then similarly to that with the conjugate root theorem, it's x plus Oh, you know what? Hold on a second. I just totally realized I made a mistake here. Hold on. Sorry. So x minus -1 minus 2i. So this part doesn't change. The minus doesn't change. This part here, it's still x minus 3 minus the square root of 5. And this will be your fourth. So is he correct? He is absolutely correct, because according to the conjugate root theorem, with every 0 that you have, you also have the opposite conjugate root, so it doubles. So this one has 2, this one has 2, and so altogether there are 4. Okay, so in a way that you can say this, or if you were to reword it, you could say yes, because the conjugate root theorem include one more 0 with the opposite sign. So -1 plus 2i becomes a negative a minus 2i. And then 3 plus the square root of 5 is going to be 3 minus the square root of 5. So your 4 zeros that you potentially have will be x minus -1 plus 2i. That's your first one. X minus -1 minus 2i, that's your second one. And then x minus 3 square root of 5, or 3 minus the square root of 5. And then lastly, you'll have x minus 3 plus the square root of 5, and there is an I right there. Or no, there's no I, just kidding. There we go. Okay, so let's go ahead and take a look at question number 2. For question number 2, it says a polynomial p of x has this following root. List one more zeros of p of x and write the second degree polynomial equation with a root of this right here. So if this is the first root, you know it's going to be x minus 6 minus the square root of 13. That's your first one. And your second one is going to be x minus 6 plus the square root of 13. And that's your second one. So then what we're going to do with this is you would have the FOIL to actually find the p of x, which is going to be your polynomial. And so with FOIL, your first is just going to be x and x, which gives you an x squared. Your outer is going to be your x and -6, or -6 plus square root of 13. So that's going to give you a negative x, parentheses 6 plus the square root of 13. Your I is going to be your inner. So when I multiply this, be careful the negative sign. You have a negative x, 6 minus the square root of 13. And then of course with your last, when I multiply this, I'm going to have a negative times a negative. That makes it a positive. And then I'm going to have 6 minus the square root of 13 times 6 plus the square root of 13. Okay, so then from this part here, I'm going to go ahead and distribute a little bit more. I'm going to distribute that, which gives me a negative 6x minus x square root 13. Similarly, I'm going to do that with the inside. So that's going to give me a negative 6x plus x square root of 13. And then immediately I noticed that I could probably cancel these two right here because there's a plus and a minus, and then I will combine like terms with a negative 6x's to make that into a negative 12x, and then these two just cancel. Now, if you take a look over here, unfortunately, you will have to FOIL that one more time. So 6 and 6 is 36, minus or plus 6 square root 13, minus 6 square root 13. And then when you have the same number inside the square root multiplied together, it's just going to be a minus 13. The square root goes away. And then lucky for you, you can also cancel these outer and inner. So we're going to go ahead and just cancel that. And so you have 36 minus 13, which is going to give you a 23. Bring down your x squared. And that is your answer. X squared minus 12x plus 23. And that makes sense because we look at your degree is a 2, which means that you have 2 zeros, and you do. These were your 2 zeros. And that's your question number 2. So take a moment, pause the video if you need to go ahead and copy it down, or you can rewind it if you need to revisit the explanation portion of this example. All right, let's take a look at number 13. Number 13 says a polynomial p of x has a root of x minus 4, x equals 7i, list one more zeros of p of x, write a third degree polynomial equation with a root x equals 4 and x equals 7i. So if your root is going to be x equals negative 4, it's going to be an x plus 4 if you put it back into the parenthesis. And given the fact that this one has an I, you have x minus 7i, which if you use a conjugate root theorem, the third one is going to be an x plus 7i. So those are going to be your third degree polynomial, 1, 2, and 3. So you guessed it, you would have to FOIL this part right there. So let's go ahead and do that. So FOIL. First is just going to be x times x, which is going to give you an x squared. Your outer is going to be x and 7i, which is a 7xi. And then you're going to have your inner, which is going to be a negative 7xi. And then your last is going to be a negative 49i squared. And then remember, if you recall, I squared is negative 1 times the square root of negative 1, or square root of negative 1 times square root of negative 1, which is just going to be a negative 1. So 49 times negative 1 is going to give you a positive 49. Then let's go ahead and see if we can combine anything. You're going to cancel these two, obviously, so that's just going to be gone. And you're just left with x squared plus 49. But then don't forget your first polynomial here. So you would have to multiply this by the x plus 4. Now you can either FOIL this, or you can go ahead and create a little chart, which might be helpful. So on this chart, I'm going to have x in positive 4 on top, and I'm going to have x squared and 49 on the side. And so let's fill in this. So I have x to the third, 4x squared, 49x, and then 196. You know that your first and last answer is going to be the top left and the bottom right. But then unfortunately with this one, you cannot combine the diagonal because they're two different terms. So your answer is just x cubed plus 4x squared plus 49x plus 196. And that is your answer. So recalling that you want a third degree polynomial, you definitely have a third degree polynomial. All right, let's go on to number 5, which I'm like, what happened to number 4? I mean, like, did I skip one or something? Let me check for a second. I did skip the 4th one, but I did find it. So here's a polynomial. It has a root x equals 5i. So you know it's x minus 5i. X minus equals a negative square root of 13. So it's x plus the square root of 13. And x minus 2, so it's x plus 2. It's asking you to go ahead and list 2 more zeros. So you know by the conjugate root theorem, that will be the first one, and then this will be the second one. Then write the 5th degree polynomial equation. So 1, 2, 3, 4, 5 is what I have. So you know this is going to be a massive taking with a lot of FOIL. So let's first FOIL this part. At this point, after doing this for so many times, you should know that first is x squared. Your outer and inner, you're going to result in a negative 5i and a positive 5i. And guess what? That's just going to cancel. So I'm not even going to bother writing it. And so then your last is going to be a negative 5i times a negative 5i, which is a positive 25i squared, which is a negative 1. So if I simplify that, it's x squared minus 25. Okay, so I'm just gonna leave that there for now. Then I'm gonna tackle this part in yellow, and let's go ahead and foil that. I like to try to like show my work on the side, mainly because then I don't have to like unorganize everything here and make it really messy. So your first is x squared. You know your outer and inner is gonna cancel because the last numbers are exactly the same, but they're opposite of each other. And so then your last is just gonna be a negative times a positive, which is a negative, square root of 13 times square root of 13, which is just 13, plus x squared minus 13. Let's go ahead and combine your like terms here. If I combine this, I can combine those two, and I can combine these two, which will result in a 2x squared, and then minus 38. Okay, so now that I'm done with that, I still have this last piece right here, so x plus 2. And then let's go ahead and just create a chart for that. So I'm going to create a box chart. I'm going to go ahead and put x plus 2 on top, and then 2x squared negative 38 on the side. And let's fill out the chart. Oops. Okay, and then just keep in mind that your first and last number or your answer is going to be this one here and this one here, but then you can't do this with a diagonal because they're different. If you look at it, they are not the same terms. So then your answer will just be 2x cubed plus 4x squared minus 38x minus 76. And guess what? Oh, you know what? I totally messed this up. I'm so sorry. Hold on a second. We're gonna have to backtrack a little bit. And I checked this because it's supposed to be a 5th degree term. And guess what? It's not. It's only a 3rd. So what happened here? I now notice my mistakes because I should not have combined these two. They're not added. They're multiplied. Duh. So let's go back to this and let's FOIL this part. So I apologize. So we're not quite to the x plus 2 yet, but let's FOIL this. If I FOIL it, it's x to the 4th minus 13x squared minus 25x squared, and then plus 25 times 13 is going to give me a positive 325. Then if I combine the like terms, x to the 4th minus or plus 12 x squared plus 325. Then I multiply that by x plus 2. Ooh, that was not a good one. So then I'm going to create my chart, and then I'm going to have my x to the 4th, 12x squared, 325, x, and 2. Let's fill in the charts here. And the bottom, now your first and last number or answer is going to be this one and this one. And so that's going to be x to the 5th and 650. And then you're going to have plus 2x to the 4th plus 12x cubed plus 24x squared plus 325x and then plus 650. And this right here is your 5th degree polynomial, and it checks out because there's an x to the 5th. So sorry about that. That was a little bit of a mistake. I added over here instead of multiplied. And if you look at it, everything here is multiplied, not add. All right, number 5. So what are the dimensions of the fish tank in feet if its volume is 176 feet cubed? So dimension means we want to find the length by the width by the height. So what are they? That's what they're asking you. So looking at this right here, I know that this right here is the height. That's my length, and this is my width. And so if I multiply that together, length, which is x plus square root of 5, times my width, which is x minus a square root of 5, times the height, which is x minus 3, that's going to equal to 176, okay? So first thing I want to do is I'm going to go ahead and FOIL the first 2 polynomials or 2 binomials. And then what's going to end up happening with this is I'm going to have x squared for the first, inner and outer is going to cancel, and my last is just going to be the minus 5. Then I'm gonna go ahead and multiply that by x minus 3. So I'm just gonna FOIL it. First it's gonna be x to the third, outer is negative 3x squared, inside is negative 5x, and then last is positive 15 equals 176. Keep in mind that your goal here is to figure out what x is equal to. So then I can plug the x into the lengths of the width and the height for x, and I can know how tall, how wide, how long in feet the fish tank is. So then what I'm gonna do is I'm gonna minus 176 on both sides to set it equal to 0, which means I have x cubed minus 3x squared minus 5x. And then if you do 176 minus 15, it's gonna give you a negative 161 equals 0. Now, I wanna find the zeros of this so I can know what the x is equal to. So I'm gonna use my TI-84. So stand by for 1 second while I set this up. All right, so now you should be able to see the screen that I see. I'm just gonna go ahead and erase everything here and then go to y equals, and keep in mind on your y equals, you are going to be typing in x cubed minus 3x squared. So I'm gonna go ahead and do x cubed minus 3x squared. And then it is minus 5x minus 161. So minus 5x minus 161. And then I'm just gonna hit graph. So I can't really see my graph because if you think about it, your last number is 161. So obviously probably requires a little bit more space here. So rather than playing with the windows, because that can, take forever, just go to Zoom. And then from Zoom, you're gonna go down to number 10. To Zoom fit. And so what this will do is it'll automatically fit the window to accommodate how long or how big the picture is gonna be, or your graph is gonna be. And so here, look how beautiful that is. You can see it perfectly. And you see how where it hits this part right here, it's 1, 2, 3, 4, 5, 6, 7. So your x is equal to 7. Now, if you're not sure and you don't believe me, go to second trace, then go to 0, and then you're gonna move your little cursor right below the x-axis. Hit enter, see the little triangle there? Then you're gonna go above the x-axis. Hit enter the second time, you have the second triangle. Hit enter the third time, and it's gonna make an estimate. And if you look at this, 0x equals 7 and y equals 0, which is exactly what you want. Okay, so now that I know that my x is equal to 7, I can actually go back to this and finish finding the dimensions. All right, so based on this, x is equal to 7. So x is equal to 7. So let's find the dimensions. My length is going to be 7 plus the square root of 5. My width is going to be 7 minus the square root of 5. And my height is going to be 7 minus 3. So grab your calculator. 7 minus 3 is going to give you 4 feet. That's the height. 7 minus the square root of 5, that's going to give you 4.76 feet for the width. 7 plus the square root of 5 is going to give you a 9.24 feet for the length. So when they're asking you for the dimension, you will say it is length 9.24 by the width, which is 4.76, by the height, which is 4 feet. And that is your answer. All right, you guys, that's all I have for you. So make sure you guys complete your Math Excel and make sure you go back to the video if you need some additional assistance in addition to your Math Excel assessment for week 2. Have a wonderful day.